All right. Well, welcome back, folks. Now we want to jump into what's in the kits. The project we will be working on today is going to be using this board called the Bit Explorer. I wanted to just show you some of the other boards I've made over the years to give you an idea of how the Bit Explorer is different and why I made some of these design choices in making it different. The first board I ever designed is this one I call the Bitbooster. The Bitbooster is a board that is really kind of like a power user board. It's designed to get the most out of the microbit. I designed it after observing a bunch of teachers who were early adopters of the microbit. In retrospect, that was a mistake to design a board for early adopters because they were effectively like the power users, and I didn't realize that most teachers had never even met the microbit. So this board can do a lot. It has a lot of built-in features. It can run motors. It has 10 of these colorful LEDs. But it did more than what most people needed. So then I designed two other boards. This Bit Buddy, which is a small one that could be used for wearables. It's got what's called a screw down terminal. These others have the edge connector. The edge connector is how you access the other pins. So anytime you slide a board into something, you now have access to the other pins. And so that's what all these pieces here are. They show how to access the pins. And they make it easier. The Bit Buddy didn't, but it also made it a super small form factor so that I could then use this board as a way of doing wearables and very simple, easy programming with it. You'll notice that all of these boards are rectangular, and the Bit Explorer looks like a little person. And that was intentional. I would always put little googly eyes and feet on these other boards because I noticed that when you anthropomorphize the technology, it made it slightly more accessible to the students. One thing that I've noticed is when a student walks into the room and they see a bunch of these rectangular boards just sitting there, they look at each other and say, oh, today we're going to learn coding. And when they walk in and they see a bunch of these guys sitting there, they say, hey, what does that do? So now I've just changed the entire dynamic of the discussion from them hunkering down to learn to them actually wanting to do something with this. It does a lot towards getting the students more involved and engaged. So you'll see that the microbit will drop right into it. You slide it down and then out. If you pull it off, sometimes you can break this connector off. In some of the boards, I realized students were doing that. These little back pads here should have a little piece of solder, and this one that I have here actually does not. So this is a good example of that. Like right here, that is the anchor point for the board right there. I've kind of like learned through having different teachers use it and having different students break these boards what can go wrong. Another thing I want to highlight for everyone is, please, if something breaks or stops working, feel free to reach out to me. I will replace it. I want to know where things break. I manufacture these things here. I sometimes contract manufacture, but I need to know what's going on. And so often when things break, I'm never told. So I never know that there's a problem that needs to be addressed. And so as part of me modeling the design thinking process is getting the feedback from people and actually fixing things where they happen. So this is a relatively simple fix, having that soldered down. The other thing I've started to do, and a lot of your boards might not have this either, is you'll notice this one has a little screw back here. With a lot of putting in and removing the batteries, sometimes this battery holder will become loose. Also, if the students drop it. So the microbit slides into the board. And let's talk about the design of the board itself. This board uses the edge connector, so it gives you access to the other pins. The pins are easily accessed in one of two ways. One way is through these side holes down here. These side holes are designed to use either alligator clips or they can be snapped onto Lego. These holes align with Lego and are marked with what each of them can connect to. So this is pin 9, 3.3 volt, ground, pin 15, pin 14, pin 13. And then the other pins are here, pin 2, battery, ground, pin 0. That one's pin 8, and then pin 1. What I want to highlight right now is Ground is clearly marked, but you'll notice that there's one of these pins marked battery and one of these pins marked 3.3 volts. What's going on there? Well, this battery pack takes 3 AA batteries. 3 AA batteries, when they're fresh out of the case, are usually about 1.7 volts each. So 3 is a little over 5.1 volts of power. That is very nice because having 5 volts is great for both external sensors that might run on 5 volts and for motors. So if you are running motors, you will often connect to the pins marked battery. But if you're running a sensor that specifically says only 3.3 volts, you want to use a pin that's marked 3.3 volts. The other way to connect to pins is this pin connection on the back. These pins that stand out like this kind of connector is called a DuPont connector. This is a long pin that's exposed. That's a male DuPont connector. A servo motor is a female, and it will plug in just straight onto the back of this board like that. It's the kind of connector used in most servos and also in the kit I provided you. But these are a very standard low-cost pin out. I sell connections from this that connect to other objects, Grove ports, and even Lego NXT. So you can control and use your old Lego products using this board. Once again, when I was describing the pin outs, the pins that are missing, you'll notice I do not give you access to 20 different pins on the back. The pins that you have on the back here do not talk to the LED here. So you won't have access to these pins and you won't risk overlapping. The other feature that this board has, if I pull this off, this little chip right here is actually the chip that modulates the voltage. So this little chip is what gives the microbit the 3.3 volts it wants, but it gives the motors and other things pull straight off the battery. So you can have too much power here and your microbit's fine and your motors are fine. So that's what this is designed to do. The two eyes are something called a programmable LED. The trade name for them is a NeoPixel. It's a type of LED that was designed by Adafruit. They are RGB LEDs that you can control, and they're individually addressable. So one pin can control hundreds of them. And in this case, there's only 2 of them here. But if you turn it over and you see there's a 1 pin marked Neo, that pin can connect to additional NeoPixels and control them. And we will later go through how you code to them. I did have a little example here that I wanted to show of, let me pull this back up a little. I've connected to that back there, and this same board here can connect up to 256 NeoPixels. This is just giving you the rainbow, but each one of these, I could address it individually using my code. Right now, I'm just using the simple show me a rainbow. So NeoPixels are seen here, but they can do a whole range of colors, and you can extend them off controlling it. We'll get to it in a second, but I'll say it now because it bears remembering and repeating. Coding has its little quirks. The first NeoPixel of the series is not number 1, it's number 0. So in this case, if I have 258 NeoPixels, I have from 0 to 257. So if I want to only turn on this last one, I have to turn on number 257. And if I only want to turn on the first one, I turn on number 0, and all of them are in between. Well, you'll notice I just pulled out a different board to show you that the Makey bit is this board, the Bit Explorer is this board. They are identical boards in function and design. This is one I designed for Make and is based on their robot. If you want to do something in a robot and your kids are really robot obsessed and you don't want a little person with a smiley face, you can just buy this one from Make, and it's the exact same thing. Everything we're talking about here is the same across both robots. Other thing I want to talk about with these is they do come in different colors. If you buy a 5-pack from us, often you will get them in 5 different colors. I like that because it just makes it easy to know which student has which one. These are the 5 colors that we typically ship in that pack. If you wanted a custom order, we could even do other colors. PCBs come in a lot of options. There's purple, there's black, You could even print multiple colors on them. There's blue, and these are the colors you've already seen. You could also do them in white or black. There's all kinds of options for PCB boards. If you had a school district that for some reason absolutely demanded it have its own branded product, it's something we could do. Let's start with what's in the kits. Everything we are about to do, you could do with just a microbit board. Frankly, anybody's. Obviously I'm in the business of selling mine. If you already have microbit boards and you don't have budget to do more, there are ways of doing almost everything we're going to talk about. With other boards, I think it's easier and more fun to do it with mine. I've tried to design these so that it's as easy as possible for this to work. The kits you got in the mail, or will get in the mail, include two major components. One of them is the computer science activity bundle that includes a kind of repackable case that includes everything you need to do this project, but also really was designed to do almost any kind of robotics and building with the microbit. And it was what I thought was the minimum you would need to build and not get anything else. I'm going to go through this kit and describe what's in it and why that's in there. And then we can kind of talk about the second half of the kit, which is the monster bundle. But right now, it's the computer science activity bundle, and it's the one in this reusable plastic box that when you open up, you've got your Bit Explorer. I ship them with the microbit out of it, so you don't have the microbit in there. What you all got was a full microbit Go kit, which is how microbit typically sends it. If you were to order this with microbits from me, they usually show up with a microbit already inserted. There is a bundle of electronics parts that come with it. We're going to open that in a second. I also include two 3D printed wheels that work with the motors, and I'm going to talk about some features of these. With all of my 3D printed parts, I provide free access to the Tinkercad files or the STL files. So if you have your own 3D printer and you want to make your own, or if you want your students to modify them, it's very easy to do that, and you can just go ahead and do it. I've tried to make it so that I make money from selling the kits, and I provide everything else for free. And if it's not out there, I just forgot to post it. So just let me know, and I will try to get it posted and get it out there for you. I've also included the little cable that is used for uploading a program to your microbit. It's a USB cable to a USB mini. They all come with the old school USBs, so if you have MacBooks or really fancy ones with only USB-Cs, you probably do need a different cable. I can stock those instead. I do have cables that go from USB-C to USB mini. Just let me know. There's a little screwdriver. It also can sometimes be used as an awl for cardboard robotics, and I'll explain that. I say that one of the most dangerous tools in most maker spaces and most building spaces is the hot glue gun, which is why I like glue dots. I include a sheet of them in here, but glue dots are a important building tool that I recommend everybody stock up on in their spaces. They are so much safer. Also inside here is a series of reference cards. I included reference cards for the most common little things that you will do. There's an overview, a quick tour of the board, kind of like what I already gave. I did include an audio jack in here. The audio jack lets you play the sound through a speaker. When you play the sound through a speaker, you'll get a much higher quality sound out of the microbit if you have an external speaker. That said, in most classroom environments, the last thing you want is all students playing stuff through an amplified speaker because it'll just get very loud. So the fact the built-in speaker is not very loud is kind of mercifully nice, but you're still not spared what the computer speaker is going to play through the emulator. One thing I will tell you, and that you can do also if you want to in a classroom environment, is every time you travel and they walk up and down the aisle handing out those free headphones, grab a handful and bring them back to your classroom, because you can jam one of those in here so they can play with the sound, but not everybody else around them has to listen to it. The only kind of heads up I'll give you about that is this is only mono sound. So they will only get sound through one headphone. That is a feature, not a bug. That is how it's built. And so just know if they're like, it's not working. Well, no, it is working. It's only coming out of one earphone. So 5 cards in here. They cover the overview, tells you which pins connect to what. There's some simple building tips of how to do stuff, and then specific on NeoPixel's servo motors and this one thing called the I2C port. So it's written I2C. It's pronounced by engineers as I2C. It is a special port that is built into the microbit that is a specific communications protocol used for certain devices. That's a fancy way of saying that the I2C port is kind of cool because when you have something connected to the I2C port, you don't have to remember what pin it's connected to because it's just connected to the I2C port. And those peripherals that use the I2C port, like an OLED screen, like some specific sensors, can just connect to it. And the blocks that you get and you use for it will just work with it because it's connected to this port. The other nice thing is an I2C port can have multiple sensors connected to it. So this is particularly applicable for the older students, but you can get some pretty advanced sensors connected to it. There is an AI camera you can put on it. There is a time of flight sensor, which is basically a mini LiDAR that you can put through the I2C. There is an OLED screen that you can connect through the I2C. And it's a way of adding a lot of other peripherals all through one. So it's a way of getting a little extra out of it. And it's also a way of using extra blocks. So the I2C is in the back there. It does use pins 20 and pins 19. When you initially connect the I2C, you have to know how it's connected. But once it's connected correctly, you can run a lot of different devices off of that port. For those who do want to explore more advanced extensions and peripherals, I'm happy to talk to you about them. I have done a deep dive on a lot of different things out there, from heart rate monitors to AI cameras to lots of microbit add-ons, and can tell you how they work, how you might want to use them, or depending on the projects you want to do, like even the Wi-Fi modules and things like that. Last thing I want to talk about is the inside of the kit has a little card. The card basically has a parts list so that when the students put everything back, they can go through and make sure they put everything back in there. In this bag is what I call the electronics and a lot of loose parts. And so let me pull everything out and lay them out. So let's start with these motors. If you've ever done servo motors before, you have probably used these smaller blue motors, not motors that look like this. And I'm going to briefly explain to you why I prefer to use these motors over these little blue motors. That said, if you already have a ton of these in stock, you can use them just as easily. Everything we do can use these motors, but I prefer to use these kinds of motors instead. And I'll give you a quick tour. First off, there are 2 types of servo motors out there. There are what's called continuous, the ones that spin freely in one direction or in the other direction. And there are some that are called positional. The most common positional motor is 180 degrees. It can go 180 degrees from one direction to the other. Its range of motion is 180 degrees. The orange ones are continuous motors. These run continuously in one direction or another, and you can control 2 variables with them: the direction they go and the power level at which they go, the speed at which they go. This is a positional. You can control its angle. What angle is it going to be at? The reason I include 2 of them is sometimes when you're doing a rover that's moving, you need something that's moving continuously. If you need more specific control over something, it is good to have something where you have a direct control. And those of you who have spent a long time in the world of Lego motors, you know that most Lego motors, at least the older ones, were basically continuous rotational ones that you could kind of get them to do a specific angle based on how quickly you told them to go to a place. Some of the newer ones, I think, did have an encoder so that they could try to get to that specific angle, but sometimes that encoder wasn't as precise. And so the big difference is the positional ones have an encoder. They have something in there that tells them what angle they have to be at, what angle they're at, and can keep track of their angle. Whereas these have what's called an H bridge in them that tells them which direction to go in and what power level to be at. So the reason I like using this brand motors in my kits is I find they're easier for building in almost any medium you want to build in, for a number of reasons. So for one thing, they have these holes in them. So as you look at them, that they've got these little pegs, yes, these are specifically designed to work with Lego motors. So if you have Lego, you can build on Lego using these motors. And so these motors can power your Lego contraptions, and your little guy can the engine on it. One thing I forgot to review, as I talk about how this is all aligned with Lego, Lego World is an 8mm on center world. So every Lego peg is 8mm on center from each other, and it's like 4.9mm round. But if you're working in Tinkercad, a 5mm is fine if you want a tight fit, or a 4.8 is if you want a little loose. You know, the tolerances on most 3D printers are not the best. So if you want a loose fit, you probably want to do 4.8. But it's also very easy to work in the 3D world if you understand this scaling. This is exactly 1, 2, 3, 4, 5, 6, 7, 8, 9 pegs across, 9 times 8. So it's 72mm center to center of these holes. And so if I'm designing something that interacts with this, both Legos will naturally fit with it, but also I can design using that kind of logic, because that's basically how I've spaced and how Lego is spaced. So step one, these motors work with Lego. That's convenient. Step two, these holes here make it very easy to fasten these motors to cardboard and to other projects. I've provided these little nylon screws that you can use, and if you use your screwdriver as an awl, you can easily just put this over a box of cardboard, poke 2 holes into it, and then screw it on. And now that box is now a pretty good chassis for a cardboard car that your students can make. Or you can even zip tie. Also, in the other kit, you'll see I've provided zip ties. Or you can glue dot it on, or even use pipe cleaners to tie it in. But the idea is, by having these holes here, it's very easy to fasten this to something. This naturally fastens onto Lego, but if you want to fasten it onto cardboard, you can easily do it using these motors. So that's another reason I really like these motors. They work with Lego, but they also are easy to build with and fasten to things. The last dimension I like about them is, if you look at the shaft of them, you'll see it's a little cross. Why does that matter? Well, this little cross is a lot easier to design 3D printed things to than the spline on a typical servo motor. A servo motor usually has this little round thing with these very tiny teeth that it's very hard. Most 3D printers don't have enough tolerance to design something that'll press fit onto that. You can use the servo horns that usually come with it, but if you want to design your own thing, it's harder. This little cross is super easy to design things for. So like, I can build this servo horn. This was actually a piece that was designed by the folks at Strawbees that I created a little cross on. But now I can put a straw wheel on this, or I can make my own servo horns, or I can make my own 3D printed wheels that I can then press fit onto here, and voila, it's all working great again. That little cross, very easy to 3D print objects that fit onto. So as a general making kit, I really like using these motors because it just makes it easier to jump into the making and to make robust products using these motors. So that's why I use these servos. Orange continuous, gray is positional. One quirk that we are going to get into, if you do happen to have a traditional servo lying around, this is a fun thing to test. This one, for whatever reason, they made this as a 270-degree positional motor. Most common ones are 180-degree positional motor. This motor has a range of 270 degrees. This one has a range of 180 degrees. Why does that matter? Well, for one thing, it does have more range. But the other thing is that the make code blocks that are there to power a servo assume it is 180. So you have to mentally map those 180 to the 270. So if I go 90 degrees on a 180, it's going to go 90 degrees. If I say go 90 degrees on a 270, it's going to go 135 degrees. So if you are looking for precision mapping of your servo, your students will have to figure out that math of remapping some positional motors that are 360 positional motors that are not 360 continuous motors, but 360 positional. But on those, if you tell it to go 90, it's going to go 180. So it's good to know what kind of motor you've got. These are 270s. That's one unfortunate feature. It would be nice if it was easy, but hey, that's a teachable moment when it doesn't move like they expect it to move. Other parts in this kit, I have included these alligator clips that terminate on the DuPont pins. That's a very easy way to plug into the back of your board. If you want to run something with the alligator clip, you can easily do that. It plugs in securely to the back pins, and then whatever it is you want to touch, you can use the alligator clips. I've also included 4 wires. They're all together, but you can pull them apart, of different colors that you can plug in here and plug at the other side. If you only wanted to say to trigger an LED, you could take 2 of these wires, take one to ground and one to a pin, and then turn that pin on and just plug the LED straight into the wires. Now you have a very easy way of connecting an LED or a button to what you're doing. For those of you who are going to do some more making with this, I try to lower the barrier of how hard it is to make, just so that they can focus on their code. And it does come down to what is your objective, but often the huge benefit of doing the microbit for teaching code is that by building something that they want to keep iterating on, you get them to improve their code. If all their time is spent focusing on tweaking their build because things keep falling apart, they never get to their code. So a lot of the things I include and I build into these kits are designed around making it as easy as possible to build something quickly that you can then code against, and then you can focus on your code. Does anybody have any questions based on the kit we have here at this point?
Found the servo information fascinating. Do you have that written down in a one sheet or some space that explains the variations of servos?
I don't have that. I did do a video about motors where I described the different types of motors, and we can also talk about that because there are 2 other types of very commonly used motors out there, DC motors and stepper motors. And odds are you'll never use a stepper motor with your microbit. You could, but odds are you won't. But DC motors, you may want to, and there are some quirks that you need to know for that. I do talk about that there, but I can try to find a way to kind of document that. Thank you. Some of these things I stumbled upon the hard way as you're like, why isn't this working? Oh, that's what I'm doing here. This is how that works. It's often, it isn't you and your code. Often there's some quirk to how this device was built that is what's driving you crazy and that you have to understand. And that's another thing. Like often, the Microbit Go kit, which comes with the 2 AA batteries and the Microbit, 2 AA batteries does not actually power a servo very well. So a lot of times you'll get this weird stuttering function on your servo, and You're like, why is it stuttering? Well, it's because of power management. So to answer the question of can you use more than 4 motors, yes, depending on how much power you have and depending on the load. Because motors also have a feature that a motor will pull as much power as it's sometimes applied. So it'll stall out for you. A servo motor will stutter in weird ways because it has a built-in H-bridge into it. And we'll discuss what an H-bridge is later, but often the issue with powering multiple motors is the power to the board. And if you're doing a lot of motors and they have a heavy load or there's heavy torque on it, then you may need an external power source. And we can talk about how best to do that. One of the things I do when I want an external power source is you can buy these like plug-in batteries into like a USB or something. This is a 5-volt kit that these are basically dummy batteries that I can put in, but this is the one that provides the power. But now if I'm going to do a project that powers lots of motors and I want it to stop it from stalling out constantly, I'll plug it in. So often the constraint isn't the microbit, it's the power to it. And motors are tricky because they do pull power, just like LEDs are tricky.
Different color LEDs have different
Yes,
powers.
exactly. And I can explain that one to you as to why that happens. But yes, LEDs, they're very quirky because they pull unlimited power, but certain ones require lower voltage. So those last longer. So red is always the last man standing when you have LEDs competing with each other. And it's usually a good indicator. If I were to turn on this large thing of neopixels, as the battery would go down, you'd start to see all of them would start to turn red because that's the last color to go. It might be that you need new batteries, but that's an LED quirk. Let's see. Any other questions right now?
We more than 4 motors at a time. It seems like we can, and my students would love that.
Yes, yeah, we can. And so, like I said, that's a power level thing. One thing I will say is if you look at the back of the board here, the way I configured these pins, it is configured to directly plug in 2 servos. You have very easily, and by that I mean you have battery, power, and servo, the pin and ground easily aligned so that I can take a servo connector and just plug it straight in. So super easy to run 2 servos on this. The kit that I sent has 3 servos, and the finished monster has 3 servos. And I will show you how to do that. You basically have to create a way of jumping from these 3 to the correct pins you want to use. I also have another board that's, I've got a version here of it, that I call the jetpack that snaps onto the back of it. And the jetpack lets you connect multiple motors, but this jetpack is a primary motor driver board that lets you connect more. It's an add-on that this one does have an H-bridge, and an H-bridge makes it easier to run Lego motors like this one. So you can, if you've got a lot of NXT motors lying around, you can put them to work. To make a DC motor go forward and backwards, you need an H-bridge, and Lego motors are DC motors. If you just want to spin it, you can just use the board. But if you want it to reverse direction and have some more control, you need an H-bridge. And so we can talk about that and what that does. So to get us back on schedule, I'm going to say let's take a break now, and then we're going to dive into the rest of the monster kit and programming our first stuff on the microbit and getting in there a little deeper. So we'll rejoin shortly.